All right, so for this one, it's asking you about the vertical asymptotes. So vertical asymptotes occur when certain values of x, whatever those are, creates a situation where you have 0 in the denominator. So we have a fraction, and certain values of x will cause this to equal 0. So what we want to do is the real question that we have to find out, and then the x and y intercepts is part 2 of this, which is pretty easy to do. But what I have to do is I have to take this, the denominator of the fraction, and I have to think of values of x that cannot equal 0. Right? So there's a couple ways to do this. One way, probably the easier way to do it, is to subtract 6 from both sides. Okay. Well, let me think about this for a second. Oh no, it tells us. Okay. So let me back up a second. It tells us what the vertical asymptotes are. So it says the vertical asymptotes are x equals negative 3, x equals 1, and x equals 2. That means if I plug those into this equation, that'll make this equal 0, right? On the bottom of the fraction. And then it says the x and y intercepts of the graph of f of x are both. So we want to verify if they're true. Oh, so we still have to do it anyways. So since they give you the numbers, you could plug it in, right? So remember that this is x to the third power minus 7x plus 6. And so if we evaluate this at negative 3, wherever there's an x, I'm just going to plug in negative 3 and see what it equals. If it equals 0, then it's true. It's a vertical asymptote.
Do I need a pass to go tell a teacher that?
If you're planning on walking out of this classroom, yes, you need a pass. If you just need to pop over to a teacher or something, wait till they come back and you can pop over real quick. Okay? If you just have to ask a quick question. So anyways, negative 3 to the third power is negative 3 times negative 3 times negative 3. So this is positive 9, and then positive 9 times negative 3 is just negative 27. And then this one over here, we've got negative 7 times negative 3. That's a positive 21 plus 6. Well, if you look at that and we add all that up, it equals 0, right? Because this is 27. 21 plus 6 is 27 minus 27. That equals 0. So f of negative 3 does, in fact, equal 0. So now we do the same thing for 1. We're going to plug in 1. So I'm going to say f of 1. Oh, it's positive 1. So this one will be a little easier. We've got 1 to the third minus 7 times 1 plus 6. 1 to the third is just 1. Minus 7 times 1 is just minus 7 plus 6. If you add all those up, that equals 0. Okay? And then 2. Let's see if 2 works. F of 2.
But is it 1 to the third power is 1 because anything that's 1 to the power is always going to be 1? Or 1?
Yeah, so because you have 1.
That's a rule, right?
Yeah, 1 times 1 times 1 is 1. Right?
Okay.
So no matter, you could have 1 to the millionth power, it would still be 1. Yeah.
Okay.
So now we're going to plug in 2. So I've got 2 to the third power times, minus 7 times 2 plus 6. 2 to the third power is 2 times 2 times 2, which is 8. So we got 8, and then this is minus 14 plus 6. 8 plus 6 is 14, minus 14 is 0. So far, the second statement checks out. So this statement, part 1, so we have to verify what's true. So far, this checks out. So that, the first one is when the denominator equals 0. The x and y intercepts of the graph are both 1/3. So that means when you graph it, it means that when you graph it,
So what we just did was verify the first.
yeah, so what we did is we verified that at -3 it won't cross here. That's x equals -3, and the graph won't cross here at x equals 1, and the graph won't cross here at x equals 2. And then it's saying that, the second part is saying that here at 1/3 and 1/3, that's where the graph crosses.
That's false.
Well,
So when the
you have to like, the y-intercept occurs when x equals 0. So you just plug in the zeros. So we could just do that real quick. So the x and y intercepts, we'll do this in blue. So for your intercepts, if I have x and y, the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. So this is the x-intercept, and this is the y-intercept. Okay. Well, this one's easy to do. I could just plug in 0. So to find this, the y-intercept, I could say f of 0 is equal to 0 cubed minus 7 times 0 oh wait, I got to do the whole fraction is the problem. See, here we just did the denominator because we wanted to know if that made the denominator equal 0. But for this one, and this probably isn't the right notation, I probably should go back and change this to like G or something. Because it's just the bottom part of the function. Yes, what do you need?
There's a bathroom.
Yes.
So like.
So this, we'll call this like G, because it's really the bottom of the fraction. It's not the actual whole fraction. So just change that in your notes real quick. G of this, G of this. So, but F is this whole thing here. So I got to do the whole thing. So f of x. Oops. Let's just do it a different color just to make it consistent. So f of x is equal to, we're going to have a fraction, and I know at the bottom is it's going to be x cubed minus 7x plus 6. But then we also have to consider the top part, which is x squared minus x. Is that plus 2? Oh, minus 2. So when I say f of 0, I'm saying 0 squared minus 0 minus 2 all over 0 cubed minus 7 times 0 plus 6. Okay. Well, 0 minus 0 is 0. So on the top I have negative 2. Over here, this is 0 to the third power, which is 0. Negative 7 times 0 is 0. So I just have 6. Now if you reduce that, that reduces down to negative 1/3, doesn't it? 2 over 6 reduces down to 1/3. All right, so now the other one's a little more challenging because we have to figure out, that's the tough part. We've got to plug in 0 for y.
So really what you're doing is you're just plugging in the numbers they give you on the top in here?
Yeah. So now this one, it's tough, but it's not tough. So for this one, remember the f of x is the same as y. So I do the same thing, except now, instead of saying f of x, I'm going to say 0 equals x squared minus x minus 2 all over x cubed minus 7x plus 6. Now here's the thing. It doesn't matter what the number is on the bottom. If I get the numerator of the fraction to equal 0, then the whole thing equals 0, right? Does that make sense?
Wait, say it again, sorry.
So like, if I say 0 equals 7,
Right.
and 0 equals 3, and 0 equals, or 0 over 2, all of these are going to equal 0, right?
Mm-hmm.
So this doesn't really matter. What I really need to focus on is what makes the numerator equal 0. That's how I find the answer. So now to do that, I'm going to have to factor this. That's the tough part. So we'll slide over to the side here. We're almost done. To do that, I'm going to say x squared, I think, remember how we did this? And we said x squared and then the minus 2 here. So that means that this factors into x times x. And I think if we do negative 2 plus 1, then I get 1x minus 2x. And so if you add that up, that gives you this. So in other words, we have x minus 2 times x minus 1 equals 0. And then you would set those equal to 0. But the problem is, it tells us up here x cannot equal 1 and x cannot equal 2.
So you're good. I know that's 1 right there. No?
Well, yeah, so if I solve this, I would end up with x equals 2 and x equals 1. But because of the denominator, I can't use those. So I don't think that the x-intercept is negative 1/3. But there's one way to double check. And you would do this on, if you could use a graphing calculator, but this is the surefire way to double check. You just do this. And we would say y equals, in parentheses, actually we'll just do the division. Up top we've got x squared minus x minus 2, and on the bottom we have x raised to the third power minus 7x. Was it plus 6? Yeah, it was plus 6. And so, see this? This is our negative 1/3 for our y-intercept that we said we had, but over here we've got negative 1. Oh, you know what? I wrote that down wrong. I apologize. This is plus 1. So we can use that. Oops, my bad. So in order to make this equal 0, This would be negative 1. Does that make sense? So,
I'm confused. This whole problem's confused.
yeah, it's a lot of steps. So, there's two things they asked us. They said
Yeah, like what
that x could not equal, how do you do that? X equals 3. Yes. Negative 3. Then they said that x also cannot equal 2. Or 1.
Yeah, because I don't think like they're gonna let me use all this stuff on the test. Like that.
No, you would use the, we would do the math. I'm just showing you what they mean by that. So, I don't know where the x equals 2 comes from, but they said it. So the vertical asymptote means that this red line never crosses, this red line never crosses, and then this line is trapped right here. So what they were trying to get you to see is that if you had a vertical asymptote here and a vertical asymptote here and a vertical asymptote here, that there's no way that this could cross here and here because of the graph. But I don't think that would work. I think the easiest thing to do would be to do the math. And so when you did all this algebra, this would be wrong, because they're saying that that would be 1/3, but it can't be 1/3. So this one is not true. So part 1 is true. It says, which of the following statements are true? Well, the first one's true. The second one isn't true because my x-intercept is -1, 0. Okay?
Still a little confused on it, but I don't know.